the caveman's hidden mind. So the old story of the dumb European brute was falling apart. We now had a picture of a complex, successful, and widespread human, and the more we looked, the smarter they got. First, let's talk about their tools. We used to think of them banging rocks together. Not even close. Neanderthals created a highly advanced toolkit called the Mysterian industry. These weren't just sharp rocks. These were specialized, crafted tools. They would take a big piece of flint and carefully chip away at it to prepare a core. Then with one perfectly aimed strike, they could knock off a finished tool, a spear point, a scraper, a knife. This is a huge deal. It's called the Levallois technique, and it's like a 3D puzzle. You have to be able to see the finished tool inside the rock before you even start. This takes planning, abstract thought, and incredible skill. They were making standardized tools, which they taught from one generation to the next for over 200,000 years. And what did they do with those tools? They hunted. We had this idea that they were just cowardly scavengers stealing leftovers from lions. The new evidence shows they were the top predator of Ice Age Europe. They weren't just hunting rabbits, they were taking down megafauna. We're talking mammoths, woolly rhinos, giant cave bears, and massive bison. Scientists cracked open the code of Neanderthal DNA, expecting to confirm the story we've all been told. They thought they'd find a simple tale of a primitive species that lived and vanished in Ice Age Europe. What they found instead was an absolute bombshell. The genetic data revealed a truth so strange it completely shatters our understanding of human history. The evidence points to a bizarre and impossible origin, a web of connections that stretches across the globe and through time, proving that the Neanderthals were not who we thought they were at all. The broken story. For more than a century, the image of Neanderthals has haunted our imagination. Many people are crazy about the idea of them. They were not mythical beasts or distant strangers, but close cousins who walked the same landscapes as our own ancestors, breathing the same icy air. Textbooks and museum displays painted a grim picture. Brutish, hunched-over cave dwellers, a primitive species trapped in the shadows of history and destined to vanish without a trace. Their legacy was supposedly one of cold caves, crude tools, and scattered bones. But as you're about to see, not all things are what they seem. Fossils scattered from Spain to Siberia revealed powerful, robust bodies, wide noses, and skulls with heavy brows that mark them as different yet recognizably human. To put it mildly, they were built for survival. Archaeologists uncovered sophisticated stone tools beside their remains, hearths filled with ash from ancient fires, and animal bones split open for the rich marrow inside. These discoveries told us they were skilled hunters, clever toolmakers, and masters of survival in a harsh Ice Age world. We now know their species is at least 100,000 years older than we first thought. Despite all this, one massive question lingered in the background. Where did they really come from? At first, scholars assumed the answer was simple. The earliest classic Neanderthal fossils appeared in Europe, so the story was written that this was their exclusive homeland. For generations, this was the accepted truth. Neanderthals were a European branch of humanity, forged and hardened by the relentless cold and the grinding power of the glaciers. But as more evidence surfaced, that neat story began to crack at the seams. What many overlooked were the inconvenient discoveries that didn't fit. Fossils found in the Middle East blurred the clean boundaries between Neanderthals and early Homo sapiens. Then, the discovery of bones in the heart of Central Asia pushed their known range thousands of miles beyond Europe. Step by step, it became clear that the Neanderthal world was larger, more connected, and far more mysterious than anyone had ever expected. The debate exploded. Some scientists suggested an African origin, pointing to the shared ancestor we had with Neanderthals hundreds of thousands of years ago. Others insisted their story began and ended in Europe, where their distinctive features emerged from earlier populations. Still others proposed a much wider homeland stretching across the vast expanse of Eurasia, where waves of migration and dramatic climate shifts could have carried their ancestors across thousands of miles of unforgiving territory. The arrival of ancient DNA analysis in the late 20th and early 21st centuries promised to finally settle the debate. Tiny, degraded fragments of genetic material preserved for millennia in teeth and bones offered the chance to read a story that fossils alone couldn't tell. If DNA could be recovered, it might reveal not only their relationships to us, but also the hidden paths of their origins. Yet when the first results appeared, they raised more questions than answers. The Neanderthals stood before us as a riddle, a true genetic enigma. Their bones were familiar, their tools recognizable, but the trail of their beginnings remained shrouded in mystery. The only way forward was to dig deeper into their DNA, and that search would open doors no one had expected. This genetic trail led to a shocking revelation about our shared ancestor, our oldest relative. Genetic studies have now revealed a staggering truth. Neanderthals and modern humans are not distant cousins. They are incredibly close kin, both tracing their lineage back to a common ancestor who walked the earth nearly 500,000 to 600,000 years ago. You see, this ancestor wasn't confined to one place. They likely roamed across parts of Africa and Western Eurasia, eventually giving rise to several new branches of the human family tree. One of those branches would lead directly to us, Homo sapiens. Another would take shape in the icy forested lands of Eurasia and become the Neanderthals. For decades, fossils alone guided these reconstructions. One of the most important sites for understanding this ancient split is Cima de los Huesos, the Pit of Bones in northern Spain. It's a deep, dark cave that preserved the remains of more than 24 individuals dating back an incredible 430,000 years. Their skeletons carry traits that look undeniably Neanderthal. Strong jaws, heavy brows, and facial structures that were clear precursors to the classic Neanderthal face. They seem to be the smoking gun for a European origin. But when researchers extracted ancient DNA from these bones, they stumbled into a massive puzzle. The most shocking fact is that the DNA told two different stories. The nuclear DNA, which is inherited from both parents and contains most of our genetic blueprint, clearly aligned them with Neanderthals. But their mitochondrial DNA, which is inherited only through the maternal line, was surprisingly closer to the Denisovans, another mysterious archaic human group found much farther east in Siberia. This contradiction wasn't just a weird quirk in the data, it was a bombshell that suggested Neanderthal history was already tangled with other populations, even in its earliest stages. It completely shattered the idea of a simple, clean split from a common ancestor. Perhaps their ancestors had already encountered and had children with Denisovan-related groups, or maybe an even earlier unknown wave of ancient humans had introduced new mitochondrial lineages that lingered for hundreds of thousands of years. The thing nobody tells you is that human history isn't a tree. It's a messy, tangled web. This initial split between our lineage and the Neanderthal Denisovan line, somewhere between 500,000 and 600,000 years ago, was not an instant separation. It was a long, drawn-out process. Populations overlapped, shifted, and intermingled in ways that make it impossible to draw sharp boundaries on a map. The Cima fossils are a perfect reminder that what looks like a neat family tree on paper often resembles a braided river in reality, with streams diverging and then weaving back together again. And the deeper scientists looked into the genome, the stranger that river became. These early Neanderthals were already on the move, creating a divided world, a divided family. When the first complete Neanderthal genomes were finally sequenced, they revealed something that no one saw coming. Neanderthals were not one single uniform population stretched across the vast 8 million square mile expanse of Eurasia. Instead, their DNA told a clear story of a great divide. It split them into two main branches, one in the west and one in the east. In the west, populations thrived in Europe, leaving behind a wealth of fossils from famous sites like Vindija Cave in Croatia and countless locations across France, Spain, and Germany. These were the classic Neanderthals we all learned about in school. But in the east, another distinct group lived thousands of miles away in the remote Altai Mountains of Siberia. Though separated by immense distances, a journey of over 3,000 miles, and punishing environments, both groups were clearly Neanderthal. And yet their genetic differences told a story of long, deep isolation, punctuated by surprising reunions. The most shocking fact is how separate they were. The Altai Neanderthals of Siberia carried unique genetic signatures in their genomes, powerful markers that showed they had diverged from their Western cousins for tens of thousands of years at a time. Yet, traces of shared ancestry revealed that this wasn't a permanent split. At various times, massive waves of migration allowed one group to completely replace or mix with the other. You can see this everywhere in their DNA. Dramatic climate shifts, the changing migration patterns of animal herds they hunted, and the opening or closing of geographic corridors meant that Neanderthal populations were never static. They were in constant motion. One moment, the East might be dominated by a lineage with direct genetic ties to Europe. A few thousand years later, that group could be gone, completely replaced by a local group with its own unique history. This constant back-and-forth movement means that Neanderthals were not defined by a single homeland or a single linear path of evolution. Their presence across such a mind-bogglingly wide range shows that they were incredibly adaptable, able to survive in the frigid, windswept steppes of Siberia as well as the milder, dense forests of Western Europe. But their genetic record complicates any attempt to draw a neat line through their story. Instead of a tidy tree with clear branches, the evidence points to something more like a web, where groups split apart, drifted for thousands of years, and then smashed back into contact to exchange genes once again.